Today's lecture is based on real number, which is the first chapter in class 10th mathematics. Real number already we studied in previous classes in the session of natural numbers, real numbers, whole numbers, rational numbers, irrational numbers. Already all of this about the numbers we studied in previous classes. Now in this chapter some points we have to study. First is Euclid's lemma. Second is Euclid's division algorithm. Third, find HCF and LCM by using Euclid's algorithm. Today in this lecture we will discuss about these three topics. First topic is Euclid's lemma. Lemma is a proven statement which is used to prove another statement. This topic includes only theory because in this topic the name is lemma. Lemma is a statement, not a formula, which is used to prove another statement. So this is only short term. Second is Euclid's division algorithm. What do you mean by Euclid's division algorithm? Actually, algorithm is a well-defined steps to solve a unique type of problems. Like we want to solve questions based on real numbers, like two real numbers are given and you have to find the HCF and LCM of these numbers. So we will use algorithm which is first proposed by Euclids. So this is called Euclid's algorithm. Now first topic is Euclid's algorithm. Euclid's algorithm. Euclid's algorithm is used to solve the problems based on HCF, LCM, which is related to real number. Now, if there is a real number A, let A is the real number which can be written as BQ plus R. A which is given real number, B divisor, A is also called dividend, Q is the quotient, R is the remainder. Why we study Euclid's algorithm? Because suppose that we have a real number and by dividing a particular number then we can find a quotient. Not in every case, but in some cases remainder can be found out. For example, suppose that 420 and 130. There are two real numbers, and we have to find out a common factor. That means we can say HCF. Then there is a process, but before going to this topic, we have to learn about real numbers, dividend, divisor, quotient and remainder. Now, suppose that 420 can be factorized to, then 2 2 is 4, 2 1 is 2, 0. Next, and now 3 3 3 is 9, 3 5 is 15. Next 5, next 7. So 420, that is equal to 2 cross 2 cross 3 cross 5 cross 7. That is the factor. But when we divide 420 divide by 130, now 3 times 0, 3 3 is 9, 3 1 is 3. That means the answer is, remainder is 30. Now this remainder will becomes divisor and previous divisor will becomes dividend. Now 4 times we can go 34 is 120. Remainder is 10. Now this remainder will becomes divisor and previous divisor will becomes dividend, that is 30. Now 3 times when we go, then 10 3 is 30 and there is no remainder. So the final divisor is the HCF of 420 and 130. Don't worry, only we taken here an example, but here we go one by one step. So as a round figure, remember it. Next, सपोज करते हैं कि a equals to bq plus r, where a is the dividend, b is the divisor, q is the quotient, r is the remainder, Step 1. Topic to find HCF. Now, step 1. Choose least number. Choose least number as divisor and largest number as divisor. And apply Euclids division algorithm. Euclids division algorithm. A equals to BQ plus R. Step number 2. If remainder r equals to 0, then B is the HCF of given two numbers, given two real numbers. But if remainder does not equal to 0, then apply again the Euclids division algorithm. Euclids division algorithm. Step number 3. Apply Euclids division algorithm till remainder is 0. Step number 4. The final divisor will be the HCF of given two real numbers. That means first step to find the HCF of two given numbers. Here this is the process, and in this process this formula we will apply, and all these processes I written here, and in left side I am going to take an example. In previous example 420 and 130, there are two real numbers, and you have to find out the HCF of these numbers. Now, first step, choose least number as divisor. So, which number is least? 130. So, 130 is less than 420. So, 130 will become divisor and 420 will become divided. In this process, apply Euclids division algorithm. That means 420 is the divided, 130 is the divisor. Now we can go for 3 times, that is 390. The remainder is 30. In second step, if R equals to 0, then B is the HCF of given two real numbers. But we can see here there is remainder is something. Remainder does not equal to 0. So we can apply again Euclids division algorithm. Now next process, this remainder will become divisor and previous divisor will become dividend, that is 130. Now 130 is written here, and it should be divided by 30. So 4 times we can go. 30 for the 120. So the remainder is 10. Now again remainder is not equal to 0. So this remainder will become divisor and previous divisor will become divided. So 10 3 are 30. Now remainder becomes 0. Then stop the process here, and this divisor will be HCF of 420 and 130. So this is the process for the Euclids division algorithm. Note that. Now After the Euclids division algorithm, something processes can be used to solve unique type of problems like prove the positive integers, prove the negative integers. Suppose if you will go to solve the questions in your NCERT books, you will find prove that 3m plus 1, 3m plus 2, these are positive integers like this. The question will be written there, prove that 3m plus 1, 3m plus 2 are all of these positive integers. So, according to the Euclids division algorithm, A that is equal to BQ plus R. Here, R is the remainder, Q is the quotient, B is the divisor, A is the dividend. According to this situation, we can write here. But what is the value of R and what is the value of B? Compare about this. We can write this 3m plus 0, 3m plus 1, 3m plus 2. Here R equals to 0, here R equals to 1 and here R equals to 2. But in place of B equals to 3, 3, 3. Now, in place of M is Q. So, what is the value of R? When we write here A equals to BQ plus R, where R will greater than or equal to 0 but less than B. That means if here written is 3, so that means R will be less than 3 but greater than or equal to 0. So the value of R equals to 0, 1, 2. But we don't go for 3 because there is a relation between R and B which tells that the value of R will be less than B, but it can be equal to 0 or greater than it. So R equals to 0, 1, 2. Now process. In this condition, A equals to BQ plus R, where R equals to 0, 1, 2. Is that clear? The value of B equals to 3. Now, A equals to 3Q plus 0. Next, A equals to 3Q plus 1. Next, for 1, यहाँ पर राइट कर देते हैं हम for R equals to 1. And first step में for R equals to 0. And step number 3, when we take R equals to 2, then A becomes 3Q plus 2. We know that R is the positive integers and Q is the positive integer. So the real number A will also be a positive integer. In process number 4, step number 4, let Q that is equal to M. So A equals to, put in place of Q M, 3M. Next, A equals to 3M plus 1. Next, A equals to 3M plus 2. These are positive integers. Now, the exercise 1.